Okay, so this will be one of the last topics ng ating heat transfer. So it is all about radiation. Punta tayo dito. Okay. As you can see, di ba ang nauna nating diniscuss for heat transfer mode or the mode of heat transfer is the conduction. It is the transfer of the heat coming from a hot source going to your cold body. Okay? Where meron kang medium. Ano yung medium mo? Medium mo dyan, a solid body. Now, convection is the movement of molecules, the heat transfer that has got to do with the movement of molecules or particles in order to transmit heat from fluid to fluid. Okay? Going from your hot body to the cold body. Now, we are using radiation. Kung ang convection, meron kang yung umaakit na init dahil yan sa nag-heat up yung iyong nag-heat up po yung iyong air particles, which is also a fluid in form of a gas. And the radiation, okay? Ang radiation po, it is the heat transfer, okay? A radiant heat exchange between two surfaces, okay? Between two surfaces. Yan. Radiant heat. And this is transmitted with the use of waves. Okay? Yung, so, waves, heat waves coming from the sun, the heat waves coming from a burning coal or wood. Now, ang heat transfer, we are always talking about conduction, convection, and radiation. Again, conduction is the transfer of heat from one body to the other, okay, with a certain medium that has a thermal conductivity. And convection is the heat transfer from the movement of the particles in molecular level, okay, from fluid to fluid, pwede rin. Radiation is the heat transfer mode from a hot source to the cold source, okay, a cold body, which is done with the use of waves, heat waves, okay. And it can be calculated using the formula where always sabi natin that heat is expressed in the alphabet Q, where it is equal to ito ang tawag dito is the Stefan Boltzmann constant. Stefan Boltzmann constant multiplied to the emissivity multiplied to the area that is projected, yung area projected of the heat transfer, multiplied to the T1. T1 is the absolute temperature of the surface radiating the heat raised to the fourth power minus T2 or the absolute temperature of the surface receiving. Okay, ibig sabihin, hot source to the cold body. Okay? Okay? Surface radiating or the one that radiates heat and the one that receives the radiative heat. Okay, T2 raised to the fourth power. Okay, sa calculator natin, paano natin mahahanap si Stefan Boltzmann? If I can remember, go to your calculators, press Shift 7, hanapin mo si Stefan Boltzmann constant. I think that is 31. Oh, yan, hugis kuto. Okay? Stefan Boltzmann hugis kuto. The value of Stefan Boltzmann constant is, ito laging ginagamit, 5.67 times 10 to the negative 8 power watt per meter squared degree Kelvin to the fourth. Meron pa po bang value yan? Let us see kung meron pa. Okay. Wala na. Okay. Ito madalas na ginagamit. Convert nyo na lang. Okay? Ito kasi okay na ito eh. Huwag nyo nang gamitin pa yung sa English unit. Okay. So, E for emissivity factor. Meron niyang table. Okay. And then, yung emissivity kasi nakadepende yan if that is a perfect black body, a gray body, a white body. Yan. Perfect black body is a body that absorbs all electromagnetic radiation. Kaya kung mapapansin mo, kapag itim yung damit mo, mas nag-a-absorb siya ng init. Diba? Kapag hot sunny day, hindi ka pwedeng magsuot ng dark clothes. Bakit? It absorbs the heat very very good, okay? Matindi ang pag-absorb niya ng init. Kaya nga sa kotse, anong base color natin? Yung pinakasikat na kulay ng kotse. Sir, racing red. Championship red ng Honda. Hindi. Ang pinaka ginagamit natin na kulay ay white. Pearl white. Diba? Championship white. It absorbs all the wavelength such no reflection occurs. So, ibig sabihin, the lighter the body, the better it reflects the heat coming from the radiative body or radiating body. When radiant energy falls on the body, part may be absorbed. Kaya kung perfect black body dyan, all of it may be absorbed, part reflected, and the remainder transmitted through the body. In a mathematical form, you can express it like this one. Alpha, the absorbivity of the fraction of the total energy absorbed. R is the reflectivity of the fraction of the total energy reflected. And T is equal to the transmitted or the fraction of the total energy transmitted through the body. So that is equal to 1. Napakadali lang po ng radiation. So sa heat transfer, kung sa conduction, meron tayong catex. Sa convection, meron tayong Q, hot. Diba pag mainit ang buga, diba? Kailangan mo ng hot. Sa radiation, meron tayong kuto. Ay, paano naging kuto? Si Stefan Boltzmann kasi mukhang kuto. Ayan, no? E. A. T. Anong gagawin mo? Ito, may kwento dyan eh. Bakit itong ginamit ko? Okay. Sa conduction, bago maluto yan, bago maluto ang pansit canton, anong meron dyan? Nagte-text ka muna. Kaya sa conduction, meron kang ka-text. Ngayon, inilagay mo ng pansit canton sa convection, di ba? Anong ginagawa mo? Meron ka ng, ano yan, magiging mainit, hot. Ayun, di ba? Mainit. Nainit na yung pansit canton. Ngayon, pagkatapos maluto, you eat. Radiation. Di ba? Very good ba ang example natin? Ganun lang po natin yan makukuha. Kapag nag-init ka at nagluto po ng pansit canton, again, mag-iintay ka ng ilang minuto, hahanap ka ng ka-text. Nilagay mo yung pansit canton dito sa ating bowl. Ano nangyari? Mainit na, kaya naging hot. Ngayon, kapag radiation na, anong nangyari? Tapos na po maluto yung pansit canton, what will you do? You eat. Diba? You eat. Very good ba? So, in order for us to understand the total, okay, the collectivity of the notion, of the idea ng radiation, we better have to apply it into different problems. So, I have here 5 problems prepared. So, isagutan natin siya isa-isa. Let me take a pause. Okay, so let us continue with the problems. So, I have here 5 problems. Let us go with problem number 1. So, at what rate does the sun lose energy by radiation? The temperature, or ibig sabihin dito, the sun gives off heat energy. Okay? It is the one that loses energy. It gives off energy. The temperature of the sun is about 6,000 degree Kelvin and its radius is, by trivia, 6.95 times 10 to the 5th kilometers. Okay? So, anong energy po ang pinag-uusapan natin dito? The energy na it gives off during heat transfer is a radiative energy. Yan, binibigay ng iyong araw. So, sabi ko, that ang radiation, di ba, pag pansit canton, you eat. Okay, Q is equal to E. Tapos yung, unahin natin yung kuto. You eat. Area that is projected. T to the 4th. Ngayon, kapag isa lang naman ang binigay mo dito na temperature, isa lang yung gagamitin mo. Okay? Q, radiative. Ano po yung Saan natin makukuha to? Okay? Ito, tandaan nyo, sa calculator, note, you just have to press shift, tapos yung number dito, which is constant, 7, and then you press 31. Okay? Para makuha nyo yung value. Pwede natin ilipat. And P, ano ba ang hugis ng sun? The area projected here. Surface, yung surface, the area of the surface, okay? Sun. Ayan. So, ang sun is spherical. Okay? Trivia. Ang earth po ay flat. No. Ang sun po ay oblong. No. Trivia, the sun is assumed to be spherical in shape. And, going back to your, tawag dito, solid mensuration, the area or the surface area of the sun is equal to 4 pi r squared. Bakit? Diba nung sa nung pinoproject niyo yung area ng sphere, you are given 4 cross-sectional areas. Okay? Kaya naging ganyan. An estimate, okay? So, makukuha na natin yung radiative heat. Q, radiative, yung kuto. So, that is 5.67 times 10 to the negative 8. That is watt per meter squared Kelvin to the 4th. You multiply it with emissivity. Okay. What is the emissivity? When emissivity is not given, you assume that your emissivity is always 1. Okay? For a perfect radiating or radiative absorbing body. So, that is 1. Tapos, yung iyong area, which is 4 pi, what is the radius na binigay sa'yo dyan? Tingnan mo dyan. Ayan, no? 6.95. 6.95 times 10 to the 5th kilometers. Ang problema, naka-meters. So, ang gagawin natin dito, mamaya natin i-convert. So, kilometer. Ano pang kulang dyan? T to the 4th. So, 6,000 K. 6,000 degree Kelvin to the 4th. Para makancel natin. Yung isa dito, we have to create a tawag doon, conversion factor. So, naka-square yung kilometer mo dito. How many meters are there in a kilometer? So, there are 1,000 meters in every kilometer. But naka-square siya, so we square. We cancel all the same units para mag-arrive tayo in watts. Okay? So, meter squared, cancel natin yung meter squared, kilometer squared, yung Kelvin to the 4th, Kelvin to the 4th. Now, we have only a sole unit, which is in watts. Okay? So, we calculate. Okay. So, shift, constant natin, 31. Yan, kuto, times 1, times 4, shift pi. Yung r squared, 6.95, times 10 to the 5th. I-square natin yung value. Times 6,000 to the 4th. Times 1,000 squared. The value of the radiative energy is 4 point. Now, the value for your Q is 4.4604. 06 pala. Watts. Times 10 to the 26 power watts. That is the amount of energy that the sun gives off. Okay? That is for problem number 1. How about problem number 2? Calculate the radiation in watts. Radiation in watts per square centimeter from a block of copper at 250 degrees Celsius. The oxidized copper surface radiates 0.6 at the rate of 0.6 of the black body. So, 0.6 ng black body. So, emissivity mo dito given is 0.6. Ayan. So, Q rad is equal to kuto E area T to the fourth. Kaya lang, sinasabi dito watts per square centimeter. O the radiative heat per square centimeter area. So, Q rad divided by A equal to yung kuto E T to the fourth. Yan. So, QA is equal to, emissivity dyan, 0.60 multiplied to 5.67 times 10 negative 8 watt per meter squared Kelvin to the fourth multiplied to T in 250. Kaya lang, gawin mong absolute value eh. Ito, absolute value dapat to. Absolute value. O, di-convert mo. Yung 250 plus 273. Para maging degree Kelvin to the fourth. Yan. We cancel all the same units. Anong hinahanap dito? Centimeter squared. Eh, naka-meter squared ka dyan. O, we have to convert it. So, ilang meters po pag centimeter? So, you have 1 meter in every 100 cm. And then, we square kasi naka-square yun nandito. Cancel all the same units. Yung meter squared, squared, Kelvin to the fourth, Kelvin to the fourth. Ang natira is watt per cm squared. Yan. Calculate the value. 0.6 times. So, shift, 31 na lang. Constant, 31. Times 253. 253 ba yun? 250. 250. Plus 273. Raised to the fourth power. Tapos, divide natin ng 100 squared. Yung. The answer is, for radiative heat per centimeter squared of area, ha? This is equal to 0.2545 watt per cm squared. That is the answer. Very basic pa yung first two problems. Let us go to problem number 3. Okay. So, problem number 3. 18 square steel plate, 10 cm on a side. Ay, that is the, yung element niya. 10 cm on a side is heated in a blacksmith forge to a temperature of 850 degrees Celsius. If the emissivity is 0.6, what is the total rate of radiation energy? Okay. Q ang hinahanap. Nagbigay ka ng emissivity na 0.60. Nagbigay ka ng element on a side. Ibig sabihin, that is a square. Pag sinabing ganyan, 10 cm on a side. So, 10 cm, 10 cm. Oh, this is a square. Alam nyo naman ang area ng square, di ba? Oh. So, the radiative heat is equal to Q2 tapos heat to the fourth. Now, ito, alam nyo na ang value nito, 5.67 times 10 to the negative 8. watt per meter squared Kelvin to the fourth. Then you multiply it with emissivity 0.60. Area projected, square yan. That is 10 squared cm squared. Kaya lang dapat tayo nakameter. O i-multiply mo. 1 meter in every 100 cm square. Tapos t to the fourth, kailangan to naka-absolute value. So, 850 plus 273. Degree Kelvin na to. To the fourth, Kelvin to the fourth. Okay. So, what will be the answer for radiative heat? QRAD now, very basic pa yung 1, 2, 3. That is, let us calculate. So, shift constant 31. Nakuha natin yung value ng kuto. Times 0.6 times 10 squared. Tapos, times 850 plus 273 raised to the fourth power. May nalimutan pa tayo dyan. Di-divide natin ng 100 squared. So, the value will be, the radiative power will be 541.11 watts. That is for number 3. Very basic. Kahit sunod-sunod ka mag-solve niyan. Ang pinakamadali dyan na heat transfer in terms of solving or solution, calculation, is itong radiation. Kasi, itong emissivity, pag sinabi yung body, bibigyan niya na kagad yung emissivity factor. Ito, meron tayong constant. Nasa calculator din yung constant. Ano lang alamin mo dyan? Your dilemma here is kung hindi mo alam yung area ng square. Hindi mo alam yung area ng circle, patay tayo dyan. Okay? Hindi mo rin alam mag-convert ng absolute value ng temperature. Problema yun. So, napakadali ng radiation kasi dalawa lang yung kailangan mong alaming value. And next, eto na. Tayo magkakatan. A steam pipe having an outside surface temperature of 300 degrees Celsius, okay, passes through a room where the temperature is 25 degrees Celsius. So, merong ang inner and outer temperature, 300 tsaka 25 degrees Celsius. The inside diameter of the pipe is 80 millimeters with thickness of 10 millimeters. And emissivity factor is 0.6. Determine the radiated heat loss per 5 meters length of the pipe. Okay. Problema mo may piping ka dyan. Let us first draw it. Ayan. Yan yung pipe natin. Haba. Ayun. So, the length of the pipe is equal to 5 meters. Okay. Ano daw yung init na lumalabas dun sa pipe? Ayan. Ayan, may lumalabas na init dun sa pipe. Okay. Coming from the inside, which has a temperature here na 300 degrees Celsius. Tapos, meron tayong outer temperature na 20 degrees Celsius. Okay? Now, meron tayong thickness na 10 millimeters. Pasensya na yung drawing ko. This is T. Yan. 10 mm. Tapos, meron ang outside surface temperature, okay? Inside diameter, mula dito hanggang dito, 80. Okay? 80 mm. Ngayon, nahanapin natin. Kung ipo-project nyo, okay, yung inside and outer diameter ng pipe, yan, malalaman nyo na DO is equal to DI plus 2T. Hanapin natin si DO para makuha natin tong surface area nito. May surface area ng donut. Ano ba yung surface area ng donut? Diba? Kapag circle, the surface area po, kapag binuyang-yang mo yung circle, okay, tubo, kinat mo sa gitna, diba? Diniscuss ko na sa inyo yan. What is the area kapag kinat nyo sa gitna yung pipe? Simply, the area nung nabuo doon that is projected, yung dadaanan ng inyong heat or nung magkakaroon ng heat transfer is equal to pi d. Ano yung pi d? Times the length. Or the length times width, where pi d is the circumference. Ang dalawa, circumference ng circle. you multiply it with the length na pagdadaanan nung iyong heat transfer. Okay. Hanapin natin si DO. DO here is DI plus 2T. Meron tayong DI, meron tayong T. So, DO is equal to DI. Ano yung DI dyan? 80 mm plus twice no thickness na 10 mm. So, 20 plus 80, DO will be 100 mm. Tignan natin kung gagamitin natin siya. So, what is the radiative heat? QRAD is equal to yung kuto, yung E, area that is projected, times yung T on the hot side to the fourth minus T nung the cold side to the fourth. Yan. So, the radiative heat loss per pipe length is five meters. So, 0.6. You multiply it with E. Yan ang E. 5.67 times 10 to the negative 8. Watt per meter squared, Kelvin to the fourth. Area projected, that is pi dl. Ano ba yung paglalampasan dyan? Okay? Pi dl. The outside, inalagyan mo ng heat loss. Outside na lang. Okay? Gagamitin pa ba natin tong dulo? Pi dl. Thickness of 10 mm. The area, pi do dl. Do minus dl. Do minus di to t. Do lang. Do lang. Do lang talaga. So, pi do. Okay? Do is 100 millimeter. Okay? Tapos yung length na 5 meters. And then yung temperature change. I-absolute muna natin yan. Okay? Kailangan na absolute siya. So, 300 plus 273. Umahaba lang dahil nag-absolute ka dito. The fourth. Minus. Okay? Yung isa, 20 ba yun nandyan? 25. 25 plus 273 to the fourth. Kelvin to the fourth. Okay. Ito, millimeter. Kailangan convert natin to. Para maging meter siya, all we have to do is divide na lang natin ng 1,000. Kasi there are 1,000 millimeters in every meter. Okay? Divide na lang natin ng 1,000 to. Tapos, we can say meter na din siya. So, we cancel all the same units para mag-arrive lang is watts. Meter squared, meter. Tapos, yung Kelvin to the fourth. Kelvin to the fourth. Ang natira is watts na lang. So, we can now solve for the value. Okay, mahaba lang talaga. 0.6 times yung kuto, shift, constant, 31 times pi times 100 over 1,000 times 5 times yung nasa loob, dalawa. So, that is 300 plus 273 raised to the fourth. Dire-diretso sa isang calculator lang. So, 25 plus 273 raised to the fourth. Hindi dapat naka-ano siya. Naka-bracket muna. Okay? To the fourth. And then, the answer will be, tignan nga natin kung tumama tayo. So, the answer for radiative heat in watts will be QRAD is equal to 5339.593 watts. That is for problem number 4. Mabalan talaga. Okay. Next one. The final problem is a bit challenging kasi dalawang mode of heat transfer ang meron dito. So let us read muna. An uninsulated steam pipe passes through a room in which air and moles are 25 degrees Celsius. The inside diameter is 55 millimeters while the outside diameter of the pipe is 70 millimeters. And its surface temperature and emissivity are 200 degrees Celsius and 0.8 respectively. If the coefficient associated with free convection, so you have number 1, convective heat transfer, number 2, radiative heat transfer. So dalawang mode of heat transfer. From the surface to its air, from the surface to the air is 15 watt per meter square degree Kelvin. So ang binigay sa'yo dito is the convective heat transfer coefficient. Okay? So H yun. Binigay ito. 15. Ayan, no? H. What is the rate of heat loss from the surface per unit length of the pipe? So, the total heat transfer dito, meron tayong dalawang mode of heat transfer. Okay? So, you have a radiative heat transfer plus a convective heat transfer. Now, we recall all the formula. So, radiation mo, meron kang cute na kuto, U heat, emissivity, delta, T. Okay? T to the fourth. T to the fourth. Ayan. Plus, yung convection. Ano yung convective heat transfer? Going back to convection. Di ba ang convective heat transfer that is hot, mainit, hot, area, tapos delta T. Ngayon, the projected area there, itong problema natin. Area projected. Di ba steam pipe? Ano ba yung area projected ng steam pipe? Di ba pi dl? Yun na yun. Pi dl. Ito na yung area that is projected. So, QT now is equal to yung kuto, yung emissivity, area projected is pi dl multiplied to the T nung hot side to the fourth minus T nung cold side to the fourth. Yan yung buo. Okay? Plus H pi dl. Okay? Pi dl. Okay? Tapos, ito, delta T. So, T nung hot side minus T nung cold side. Ayan. So, may nakita kayo dyan. Pwede nating factor out to ilabas natin. Okay? So, QT. Divide ko na agad ng length kasi factor ko na yan. Di pi d. Okay. Pi d. Okay. Tapos, length. Okay. Pi d multiply to yung kuto, emissivity, tapos T to the fourth minus T low to the fourth yung cold. Plus dito, yung H, tapos T hot minus T cold. Yun. Na-form na natin yung gagamitin nating working formula. Now, we have to find per length. Q, T, per length. So, pi D. Ano ba yung pi mo dyan? Times yung D. 70. Ano yun? Binigay dyan outside. 70 millimeters. O, divide ko ng 1,000 para maging meter. And then, multiply to emissivity na 0.8. Kung tama tayo dyan. Tapos, 5.67 times 10 times 10 to the negative 8 watt per meter squared. Kelvin to the fourth. just multiply it with T hat. Okay? So, ito kasi, 200. Pag naging absolute, 200 plus 273, it is equal to 473 degree Kelvin. Yung T cold, that is, nasaan yan? 25 plus 273. 25 plus 273, that is 298 degree Kelvin. Yan. So, 473 raised to the fourth minus 298 raised to the fourth Kelvin to the fourth plus yung H, 15 watt per meter squared Kelvin. And then multiply it with 200 minus 25. Yung hot surface and cold surface, degree Kelvin. May nalimutan ba tayo dito? So, meter squared. Okay, dapat merong meter na matitira dito. Watt per meter. Cancel all the same units. Yung meter, makancel dito. Maging isa na lang dito. Dito rin, isa. Kelvin to the fourth, Kelvin, and Kelvin. Okay, solve natin. 9 natin nasa loob. May 9 nasa labas. Okay. 0.8 times, kahit wag ng time shift, constant, 31. Yan. Times, ito. 473 raised to the fourth. Okay. Minus 298 raised to the fourth. Yan. May binigay bang feet length dyan? Wala naman binigay na length. Okay, okay na yan. And then, ito muna, gagawin ko dito, yung loob, itong buong to, okay, itong buong to gagawin kong A, itong buong to gagawin kong B. Okay. Equal natin. Store the value at letter A. Tapos itong susunod, 15 times 200 minus 25, 175 na lang. Mental math na yan. Okay. Store natin kay B. Yan. And then, pagsamahin natin, i-multiply natin siya dyan. So, 70, ito na. 70, shift pi, divide by 1,000. Multiply natin kay A plus B. Recall natin si A, plus recall natin si B. The answer will be, the total heat transfer for the system is equal to, per length yan 997.934 watt per meter length. That is for radiation po. So marami po tayong problem dyan about radiation. Nandun na yan sa YouTube, naka-upload na. And this is just a refresher for you. So I think that will be all for radiation. Let us take a break.